Hi everyone, it's Nono here, and this is the Machine Intelligence for Designers live stream that I'm doing every Thursday. And if this is the first time that you're connecting, I'm Nono Martinez Alonso, and we're gonna get hands-on with things that have to do with creative coding and machine intelligence. On previous live streams, we've done things from live podcasting for the Getting Simple podcast to doing machine learning notebooks, trying to understand algorithms, create interactive web applications and deploy them to the web, and many, many things. So I'm going to get started. And today we're going to see Bézier curves and AI sketch vectorization. We're going to continue on that topic. As a reminder, as always, I'll ask you to like the video if you want to support the work that I'm doing here with the channel, and subscribe if you want to get notified when I go live next or when I upload new videos. You can also join the Discord community. So this is a Discord server. This is the URL. You can go. There's a QR code up there and also a URL down here. And last week we were already working on this AI sketch vectorization topic. We've been working on this for many weeks because it's a complex topic. And yeah, you can go and watch that at nonodomas.live/64. I would also appreciate if you can tell me if you can hear me okay, if you can see me okay today, and remind you that you can send questions to the Getting Simple podcast at gettingsimple.com/ask about the latest episode or any previous episodes. And what are we going to do today? I'm not updating this slide lately, but I will say that hi everyone, it's Nono here, and this is a video part of the intelligence and sketching playlist. Today specifically, we're going to continue talking about AI sketch vectorization and the virtual sketching framework. We've done more videos before on the topic, and if you go back, you can see what this framework can do for you. It's a new way to vectorize raster line drawings with machine learning. Specifically, it uses a recurrent neural network architecture, and then we have a decoder on the other side. And then there are other things that we're trying to understand here on the live stream, like how it uses quadratic Bézier curves or other concepts like differential rendering and differential pasting. These are some of the results that we've seen on previous live streams, and we're gonna, I'm not gonna go in detail because we've talked about these things on previous live streams. These are some other outputs that we've got. These are from my own hand sketches. This is a way in which I was rendering my sketches or vectorizing them and then seeing a live animation of those sketches being drawn by this neural network, right? So at the end of the day, what this is doing is showing the canvas window that it was setting at every time step, the size of it, and drawing the vector strokes that the network actually calculated, which, I think it's really impressive. Just off the hook, we built a, a notebook. So there is a collab notebook that you can access on the links of Live 64. If you go back to Live 64, you can see it on the chat, or you can probably find it also on the Discord server. I see also Jose Luis is live with us. Hi, from his personal account, not from Parametric Camp, but sometimes it depends on the day, I guess, that you get from one account or the other. And yeah, so this is just a recap. SVG export, we're not going to talk about now. The recap of the Colab notebook, which we saw, and some next steps, right? We wanted to get the MPC file, read the strokes data, and draw the strokes. These are the coordinates that we were getting, but I've done some homework offline, reading the paper to try to see if we can understand the type of data that it's using. So today we're going to see Bézier curves, AI-based sketch vectorization, and try to understand them. As a high-level overview, I'm trying to prepare a brief lecture on, or just like a few slides on what Bézier curves are, how you can render them, and how we can understand them, because for this paper, it's important to know what we're getting as output from the model and those are quadratic Bézier curves, which means that we have three control points, end and start, and then a point in the middle. So if we have a quadratic, if you have a line, you just have 2 points that you can see here on the left. But you can also happen to have a quadratic line that is aligned if the end point and the start point, the line between them coincides with the control point, right? If that doesn't happen, you have a quadratic Bézier curve that we'll see this one in the middle. We'll see later an animation of how this is actually rendered. And then on the right, we have a cubic Bézier curve, which is actually an interpolation between two of the quadratic curves, right? And we can create what are called Bézier splines if we create a different set of basically many control points, one after the other, into creating a curve. You might be familiar with curves like this from modeling software like Rhino, or maybe even Adobe Illustrator or other programs. All right, so this, you can see there is a citation on the bottom right. So I got these diagrams from javascript.info. There is I think there is an EPUB, but you can read it online, an animation, CSS animation book. And this one particularly is a chapter about Bézier curves. And what you can see here is that if we join the three control points with lines, we have this parameter t. It's kind of like just a parameter that goes from 0 to 1. And what you would do is that basically there is a line that goes from this straight line up to this one, rotating. And at each point in time, you can calculate one of those points of the actual curve, right? So this is basically what would be the tangent of that at that point. And I think what happens is that you rotate. So at that time, this is 25% of the length of the curve, and then here on the right we have 50% of that length, and also 50% of the rotation. We'll see how to calculate these ones. We're going to use a few methods off the shelf, and then at some point we'll try to implement it on our own. And this is an animation also from the same website, which is super cool, which does that process, right? So we are rotating that curve, and this happens, right? So we are actually, it seems like we're interpolating between this and this curve, like rotating. Well, actually not interpolating, because that would be actually just a straight line here. But yeah, so this is the process of how you draw the Bézier curve. And with this, I'm trying to refresh my mind with how these geometry functions work, and also to learn how to implement them from scratch and use some helper functions that we can find in things like processing and P5.js. All right, so we can define, depending on the type of curve, as we saw in this slide, right? So line, quadratic, and cubic. We can define those with these formulas, right? So the one that we care about today is this one here, the one with the 3 control points. And what you can see from the formula is that by replacing this formula for x and y, we can get the coordinates of that red point that we were seeing on the diagram before, right? So this that would be the coordinate. The point would be the xy result of that equation, and that actually is shown here. So for a 3-point curve, we can calculate x and y, as you can see here, right? And that t is the parameter from 0 to 1. All right. So okay, let's code. Let's take a look at some other things. And the thing, or the reason why I got to talk about Bézier curves today, is because if we open the virtual sketching framework paper by Simo Serra and Howard Mo, and like the researchers from China, Canada, and Japan, including Huawei Technologies, Waseda University, and Sun Yat-sen University. Okay, so this paper, the overall concept is easy to understand. So we feed it a line drawing, so we can maybe zoom into some of these diagrams, right? So we input a clean line drawing as a 1024 by 1024 image, and then we get the output vector line drawing on the right. So this is meant to be a raster, and this is the vector output, which is super nice. This is clean line drawing image that doesn't have like jagged edges or any kind of imperfections along the lines. And if we take a look at this image here, so this the stroke order image, this is actually for you to get a sense that each of these lines have been drawn at a different time step in the order, and each of those reflects a different stroke, and those relate to the animations that we saw before. Okay, so this is the paper, and today I am sharing screen from my remarkable tablet, and if we zoom into here, we have this chapter that talks about stroke generation and stroke representation. And the stroke uses this stroke 3 format with like the delta between the start and end point, and then the p, which is the state of whether like the pen is up or down. But there are also some other things that this paper augments that nomenclature, or that way of specifying a curve or a line with a set of things, right? One of them is an intermediate control point to form a quadratic Bézier curve, as we just saw. A width factor, this is the thickness of the stroke, W, and a scaling factor, S, which controls the window size, right? So that's the window size that we saw, the red window that we could see on the former animations. And really quickly, let me go to my desktop. Here I do have an animation. So I had on my computer, I had this doodle that I scanned from, actually this is, I'm not sure if this is the original image. Yeah, this is an edit, but this, you get, this is hand drawn, and the actual, let me actually just grab it. So I have it. Don't have it here. All right. So this is just an edited version of a hand sketch made with a pen and scanned with a normal scanner. And this is the animated version. Actually, this one is a bit faster. Yeah, and this is the vectorized version. In this, this is a GIF, so it's a bit pixelated, but you get the idea, right? So from a hand sketch, we get this has high resolution. Okay, so we get this, which is a vector representation of the same hand sketch. What you can see is, because this is not a clean line drawing, the network is actually making a bunch of more strokes on top of my drawing to make it look exactly as the original, right? You see these artifacts here. And actually, if we close, so let me see if I can, yeah, if we see the frames of that GIF, right? If we compare this moment where this is, let's say, a bit dirty with this one, so this is cleaner. And why it makes it dirtier is because it tries to make it look more like the original sketch that I had, right? So and that is just that the network internally has a way to measure when it's drawing things if those strokes should stay or not, depending on how much it resembles the original sketch that we're trying to vectorize, right? All right, so going back to the paper, we have here this equation. Let me see if I can zoom in properly. Maybe. Okay, so let's let it stay here. So we do have the equation. So this is a stroke at time t, and we have the control point, the delta between p1 and p2, the width factor, the scale factor, and the pen state. And I think this is right? I think I'm trying to understand this paper, so some things might not be super refined yet, but as I understand it, they talk about this intermediate control point XZ, which is here. We have the delta and the p; those come from the stroke 3 format from SketchRNN, and then we have here the stroke parameters qt, which is x0, y0, x1, y1, x2, y2, ro, r2. And these here, the first three, I think these are the control points. I'm not sure what r0 and r2 are. We can take a look at them. All right, so next page, these talks here about the Bézier curve, right, where we have the control point. Yeah, so we do have the width at the end and the width at the beginning, I think. Let's take a look. So R0 and R2 denote the widths of P0 and P2. After pasting, the pen state is used to decide whether this stroke is drawn or not, right? So maybe I can highlight this so we keep it for next time we look at the paper. Highlighter, and I'm using the remarkable tablet with the pencil and sharing screen so you can see it. So let me zoom into here. All right. So here, the starting control point should always be exactly at the middle of the dynamic window. So this is the starting control point, and the dynamic window, xy, x1 and y1 and x2, y2 are derived from the stroke, and r0 denotes the widths. Okay, so this and this and this are going to be highlights. All right. The pen state is used to decide whether this stroke is drawn or not. Okay, so we need to see also how the pen state is inferred. That might be, that might be inferred from the model, so it might not happen as I mentioned before. So we have this P, and then we have R2. Let maybe. Okay. Okay, here we can read relative moving and scaling. At each time step, the virtual pen, along with the dynamic window, moves to the ending position of the predicted stroke. It is not necessary for a stroke to be done. Sliding to a different part of the image, the model can choose not to draw the stroke by setting the pen state to pt equals 0. We call this movement only. Furthermore, the model can choose to change the size of the dynamic window at each time step by setting ST, which allows enlarging or shrinking the window size given the cursor movement. And scaling factor, we can define the dynamic window update rule as, and this I haven't understood yet, but this is given the cursor movement and scaling factor. We can define the dynamic window update rule. Okay. Uh, Jose Luis, what is really cool? The paper, sharing with the remarkable, my sound effects. Okay, so yeah, so we're trying to understand this. For me, I have to say it's I'm trying to make an effort to find the time to spend more time offline understanding these papers, and hopefully we can get to at least understand this one in depth, or some others. But there are many different parts that are definitely not trivial, and we go from paper to high level to code really often, and the intention is that we end up understanding a bit of everything. All right, so maybe now that we have it here, this acts a bit as my own slides, so maybe we can set the view to landscape. But I cannot rotate the paper. Can I? Maybe not. Okay, so we'll leave it as it was. We'll just zoom in to here, which is going to be a bit pixelated. All right, so here we do have the model architecture, and now we can start understanding a bit more what these things mean, right? So we have W1, which is okay. So there are two different things. So we have because here we do have this mention to a W that is lowercase, and that's the variant thickness. But there is a W uppercase that is actually, I think, referring to the window width, right? So to the canvas width, right? So this is W1, WT minus 1. All right, so we were talking about, so let's leave this aside for a bit. Let's minimize remarkable. And we can go back here. So we have this cool animation. And so this animation, we want to try to draw something like this. And we're going to do it in a fairly interactive way. I have to say I've been taking a look at some stuff that we could use today. So first thing, I'll do a really nice, so I'll make a reference to this, which is the javascript.info site. If you go to javascript.info/Bézier curve, you're going to find this information. I'm going to be pasting these things on the Discord server and the video. So right now on the chat on the YouTube video, I've got all the things from here, and these are actually interactive, so you can play with them. But we're gonna try to create our own with P5.js. So I do have. Thank you. And
exploring what the
I see. So because Jose Luis is here. If you're watching, we've been going for 30 minutes now. If you're watching, I'm gonna plug Jose Luis's channel here because I think it's really important to congratulate him for doing his 100th live stream tomorrow. So if you're interested on the topics that we're covering here today, you should definitely go. He's covering a lot of stuff on computational design and geometry and interactive, how to draw things and do things for designers and artists. And tomorrow, so I'm gonna set my reminder so I don't forget. And tomorrow he's live streaming and doing his 100th live stream, right? So this is a big moment. He said last week he promised. So you promised that that tomorrow there'll be something special. So we're looking forward to it. And I invite you to go here and go to his channel. I'm gonna move myself so you can see it properly. Um, so that's parametric camp. Let's zoom in here. And tomorrow is the 100th. My hand cuts. That's so tomorrow is the 100th. Let me do it like this. Maybe we can share it later. All right, that's for me, so I can maybe share it later somewhere. And yeah, I don't know who went here, but there are 2 likes now, so that's a really big recommendation from myself. W is a function defined under Q hat. Okay, we'll take a look at that now. So let's see. Oh, okay, so Jose Luis, this is a cool thing of having people live that has 2 or 4 or 6 more eyes, or how many people are there. QT hat and WT hat, this is a dynamic window that basically changes the sliding window that we can see on the animations. The animations are really cool because it makes you understand kind of the order in which the model is reading the sketch and it's looking at the strokes. WT max, W min, WY, WI. Okay, and we have to continue reading this, but I'm not going to do that now because I don't want to bore you. I want to have some more pre-existing knowledge before I start reading the paper. Otherwise, this is a bit not dynamic. Okay, so now that we've talked about Jose Luis's 100th stream, I'm going to go and I'm going to show you 2 different things. One is Daniel Schiffman's video. So this is an awesome video that I found while looking at how to draw Bézier curves and stuff. So I was just trying to take a look at some things that were already there, and this was the first video that showed up. So let's quickly play a few bits of it. I would definitely recommend you to go and take a look. I'm trying to do like a really reduced version of this and not such a nice video.
Involves just one control point. So I'm going to renumber these points now. The middle point is the control point, and it's like a gravitational pull. If I were to pull this point down, the curve would also be pulled down. And if you're thinking what I'm thinking, a cubic Bézier.
All right, so the video goes through many things, and today we're gonna take a look at the Bézier curve function and the lerp function. But yeah, I don't know. You can go. I'll probably have to rewatch this video or watch it in full. It's a really nice resource. I will also posted to the links on the. Okay, so Jose Luis is saying that they have he has guests tomorrow on Parametric Camp. I'm gonna post here Dan Schiffman's video, and I'm gonna also post Jose Luis's live stream. Awesome. Can you spoil us with, or are the guests secret for tomorrow's live stream, Jose Luis? All right. So that was one reference, and then there's another reference
And why
by Freya Holmer, which I'm gonna silence, but also this is incredible production value, right? There is an incredible production value in this video. There's so many animations and so many things that I can't imagine. Like, if you watch the entire video, you're probably gonna learn a lot. So I'll recommend you to watch this video. I'll also post the link to the chat, and yeah, you can see a bunch of stuff here. And this is her explaining and thanking a lot of people and things. Okay. Yeah, I think these are awesome. Okay, so this is Freya Holmer video. The beauty of Bézier curves. Okay, and I do have now the references. This is just for P5JS, but and yeah. So let's take a quick look, and this is because we can do it on the sketch editor online, and the Bezier curves are natively supported by P5JS, so we can go. Yeah, bye, Jose Luis. Nice to see you around and catch up, and we'll see you tomorrow. Looking forward for those secret guests. Okay, so P5JS playground or editor. So editor.p5js.org. Motoreta sketches, blah blah blah. Okay, so for those of you who are not familiar with P5JS, we do set up our canvas and then we get a preview on the right. So if I click on auto refresh and click on play, this is our canvas. I could make it 600 by 400, so it's landscape, right? So that way you can see that this is live updating. We can go now full screen, but let's first take a look at the examples here. So we get a vertex and then a Bezier curve. Okay, and we're gonna see here we have a function maybe to try to understand a bit better. So anti-alias true. So if we draw here, maybe we do smaller canvas. Might not make sense to make this anti-alias if I'm making the canvas bigger, because it's gonna pixelate. Right, so we'll see this better. So let me sit here, stroke width 3, I think. All right, so let's make this for now 10. So we're making the stroke weight greater. Yeah, not sure. I want to make the type bigger without this pixelating, but it's fine. Okay, so we now have this possibility to draw here. I'm not gonna go into detail right now in talking about what P5JS is. Quickly, we'll mention that this is the JavaScript port. It was the unofficial port, but I think now it's officially supported of processing, which is like an like a Java editor for doing things that you can see here, right? And this editor for the web seems like something I hadn't seen. That seems really cool. And here we're also using Bézier curves. Okay, so let's go back to P5. Let's make maybe this point 2020 so you can see it. And yeah, so right now we're just specifying a line from point 2020 to whatever my mouse is on the canvas. This is called, so this gray area is called a canvas. And now what we want to do is reproduce something like we have here. So we have a vertex. So let's basically make a vertex at 2020. And now we're going to make a Bézier vertex. Bézier vertex. And this will not work because we don't have the coordinates now, but let's try to see. So let's first draw a few points. So let's draw circle, for example, at 30, 20. All right, so we have that circle there, and we can say that our stroke weight actually is going to be 1. But this is going to be 10. All right, and we're actually going to set our anti-alias so this renders more smoothly. Okay, so let's actually mark the points that we draw above them. That way, if I draw point 2020, I see that that's there, right? And maybe let's make the radius, let's make it 6. And we can now use that variable here. Stroke weight, blah, blah, blah. The circle is going to be radius. All right. So here now we do have just a line, which I'm going to remove. And now we're creating a vertex at 2020. So now we're going to make it go to 4040. Let's see, nothing happens. Maybe 5050. And now we add 6060. So I'm just testing out if something happens here. So here we do have 6 parameters, and now we click on end shape. So we write end shape here, and that's our line, right? So let's move this point to 60, right? Okay. So we don't want to fill, so we're gonna do no fill. And so we'll draw all these points. So we're gonna draw 40, 40, 60, 50, and 60, 60. And maybe we need to make this a bit bigger so we can, so it doesn't collide with what we're seeing. So something like that. All right. So now we get that, and I'm gonna move this so we could actually get it to be more parametric. And what I'm gonna do is that for the point in the middle, I'm actually gonna go back to using my mouse X, mouse Y. So we'll also use these to draw the control point here. All right, cool. Okay, this is nice already. So you can see what's going on there. And I could actually, so the background is being drawn all the time, but for some reason it's not being drawn. Hmm. Why does the canvas not? Mm, this is a beginner question, but I'm not sure why the canvas is not getting cleared. Mm, for some reason, I think this should actually not be stained black all the time. So the draw function gets called on every single frame, right? That there's a re-render needed. Not sure why. No idea. Okay, one sec. Okay, so the point, so it's only happening with this. So this is good, and begin shape. Okay. So we're actually adding, okay, so we were adding and adding and adding curves to the same shape. We were not really we were not really re-rendering. We were always using the same curve instance, right? So let's make this a bit bigger. All right, and cool. So we will say that these points are going to be filled by white, and yeah, but we don't want this shape to be filled. So no fill, and we'll just remove this line. Okay, right. So what is that middle point doing then? Okay, so let's see. Let's actually let's actually see the points. Um, so P0. Okay, so let's try to see. So what is this Bézier vertex? X2 x so x2 y2 begin vertex. Oh, okay. So that is another control point. So we're getting okay. So we're actually so this is a cubic vertex. So I guess that's 100 and 100. So we could put this one here. All right. So if we use the same start vertex, this is okay. This is confusing because we don't have the right um variable names. So it's point 1. So point 1, point 2, point 3, point 4. And I'm going to say that this is point 1. This is going to be 2020. This is going to be mouse. So this is going to be 0, 0. And this is going to be 160 and 160. So here we're going to do P1, 0, P1, 1. Same here. Every time we're going to say that P3 equals mouse X max Y. So this is P3. Hey, John Mark. Um, do you think that's because these ones are too long? One day we'll have awesomely edited videos that you can watch in like 5 minutes and learn everything. Wouldn't that be awesome? All right, then now that we have these variables here, so we can draw point 1, so point 2, which is right now the same, point 3, and point 4. But John Mark, thanks so much for popping by and saying hello. All right, so okay, so we got this, and now easily I can say here this is 300, 300, and we have our Bezier curve, right? So we're gonna put this at 100, 100. All right, so this is our first Bezier curve, and we could also draw the auxiliary lines. So we could say fill, is gonna be this color. So we can actually define to make this a bit better. So this is, let me see. So what we have here, uh, let point equal I think I can use this arrow syntax here, right? X and Y, and this X equals X, this Y equals Y. So we do object-oriented programming, and we could say new point, and new point. Bezier curves, live, 65. All right, so let me see if I can log into here. All right, so let's try this out. So I'm gonna open a new editor. I'm gonna paste what I was doing. I'm gonna save, and now I'm logged in as my username, and I should be able to save with this name. Okay, sketch saved, and we're gonna close this and this. All right, so now that we've converted everything to points, so point classes, we can actually go here, and instead of doing this, we can do X and Y. And this is probably going to be faster in Visual Studio Code. I do see a question that came through by Sorab Matre. So thanks for the question. I'm not sure if you're still live there watching, but I received the question and we'll answer it in, I'll prepare an answer and we'll do a live Q&A video. Thank you for your question. He sent it through the form at gettingsimple.com/ask. All right, so what I was gonna do, I'm just gonna open Visual Studio Code quickly here, and I'm gonna replace everything that says 1 with a Y and everything that says 0 with an X. That way we don't have to do that manually. Great, and this is failing, so P1 to pi. P3, P1y. All right, cool. So this seems like it's working now. So we're drawing a Bezier curve, and what I was gonna do is, okay. So let's see. We have to, now that this is working, we're gonna draw a line from P1 to P3, which is effectively P2, right? And from P3 to P4. All right, got it. So we got this triangle that we were seeing before, and maybe this is the stroke, not the fill. All right, cool. And our stroke. All right, let's see another color that is a bit more, that is a bit lighter. Okay, so maybe a bit more red. All right, so I think that should work, and we can actually draw this before the curve, so it goes to the background, and this can actually be thinner than the actual line. Okay, 0.5, can we do that? All right, and this can be actually 0.5. Great. So we do have this thing here, and we can zoom in, and this is our Bezier curve being drawn. So this is quadratic. It's cubic, but because we're hiding one point behind this first vertex, it's actually like a quadratic one. So we only have 3 control points, as you can see. All right. What do we want to do now? There is this other function. So we've drawn this function, and there is another function that is called lerp. We have linked from here. So it's this function called, and let me see if I can share this. So if somebody comes and opens this, they play it, they get access. All right, so this is the P5 sketch. P5JS sketch Bezier curves. All right, so this is our, maybe we can leave this one here. So this is Bezier curves quadratic, right? And now we can duplicate and continue from here. So this is a dupe, and okay. All right, so let's see, where do I have my sketches? My sketches, right? So now I have these two, and I can go to my sketches, rename. We're gonna put this like this quadratic, and then we're gonna open this. All right, so we do have, so if we continue with the same one, look how odd this is, right? Like when we start, the mouse X and the mouse Y are in 0, 0, so we get that curve drawn. So if I refresh again or stop and play, so maybe we can start the how can we change that? Mouse X equals 200, mouse Y equals 200. Is that possible? All right, so I guess what we can do is all right, so we get that, and that is actually great. So yeah, actually, I just realized these parameters here. So we could actually um, reset this one. So we could just name them here. So let's do one thing. So I'm just gonna do this quickly in Visual Studio Code. So we can actually get these, put them here. All right. Instead of let, we'll just put the variables, and in here we're just gonna create the variables. I think we can actually do this. Don't remember. Okay, I'm not sure what's going on with Visual Studio Code, but it's going really slow. Or my keyboard. Oh, okay. Actually, my keyboard is not working. Okay, let's try this out. All right, so that works. And the good thing is now if we make the okay, if we now make the canvas smaller, 1 second, so it stays the same because we haven't changed anything. But because we're setting these things here, we could say this is actually width by 0.25, height by 0.25, and this is width by 75 and height by 75. All right, so this is now parametric, and if we set this to 30 or 300 or 150, the drawing that shows up here still gonna make sense. Okay, we can actually save this to the previous sketch because I like this a bit more parametric. So that and this, great. And we're gonna still leave this at 400 by 400. All right, so this is our sketch, and this is the second version. So let's make this also 400. Cool, so we have this here, and we're rendering our Bézier curve. And what we would like to see now is, so now what we're gonna see is this lerp function, which creates a set of components. So create vector lerp. So let's let's just try to do this. And so on the setup, we can do this and then print v, and also print v here. vlerp. What is lerp? All right. Oh, okay, I see. So v, so in some way, why are we seeing this as 220 if, all right, so we gotta make a copy. And all right, so this actually changes this vector. So v, what's happening with this ler function is to interpolate, right? So we have this 110 and then we have this 330, and we want to interpolate to in between both. And when we do that, we actually get this vector, so it's in between the two, right? So what we can do here, yeah, I don't know exactly how you do that with this, but we can look at Daniel Schiffman's video and see how he does it. So what I want you to see here, if we make like this lerp function work for us, we could go to our two. So let's add some code. Render display control points. This is display. This is the convex hull, which would go also through the bottom as well. But and then here we are display. So this is the convex hull, and this is actually displaying the Bézier curve. Okay, so this is update mouse. Well, this is probably evident, and we here write initial point, and this is like some setup, and this is some settings and variables. All right, so again, once more, I'm gonna go to the other sketch and leave it as this is here. And now we're gonna go back to this one. And because we have the convex hull here, what we could do is interpolate lines. And we could say that we have, so create vector. So let's say that v1 is p1x, p1y. So here we're creating a vector of 3 components. Let's just print v1. All right, so we can just do it like this. And so what we want to do, because the endpoint is the same, we can interpolate simply, this P3 is the same. So we can have, we can create here the V3, let's say, or yeah, V2, create vector with P4X and P4Y. And now we have a vector for this point and this point. And we want to interpolate. So, for example, we could say Vx equals V1 copy lerp, and then we'll add this V1x and V1y, which actually then we don't really need this, right? We can actually interpolate with directly with P4 and P4, so we don't need to create this vector. And now we tell it we want the one in between. So we print, so console log, did I say print before? I'm so used to coding in Python now. Okay, so we got this one, and this is 100. Okay, let's see if we can do this. So console log, and then we do v1x, right? v1x and v p4x and vxx. Okay, so let's see this lerp function. So v1 has p1 and p1, which is 100. And I'm copying it and running lerp with p4, which is 300. And if we're at half of it, we should be getting 200 here. Vx. Well, what if I do this? Lerp. All right, so let's still create vector with p1. I don't understand this fully, so let's just do here. So we have v2 is going to be create vector px p4y, and then we're going to do v2 lerp so v2 is going to be a v1 copy, and then v2 we're going to make a lerp, and then v2 is here, and we're still not getting it. Why not? So lerp, so we create a vector which is at 100 and 100, and 100 and 100, and then we have this other one which is at 300, 300, and then we get this one which is at 100, 100 for some reason that I don't understand. And all right, okay, let's post this. lerp. Maybe. But P4. Okay, so create vector 0, 0. Create vector mouse x minus y. P5 vector. Oh, V1, V2. That's weird. I mean, that's not what I see from here. Oh, okay. Yeah. Okay. So my bad. We can go back. Okay, so then I'm doing this wrong. Okay. So we do, yeah, so no, but this is, oh, 0. Okay, okay, okay. All right, so this is a three-dimensional function. So we, even though we can interpolate between two vectors, what's happening here is that I'm doing 2D, but I need to set this to 0. So I have to do here this copy. And now we're talking. Okay, now we're getting the right thing. So now we're getting 100, 200, 300. All right, and now I can remove this. So we have V2, and this is actually Vx. And we could do a line between P, so Vxx, Vy, so Vxy, and P3x, P3y. All right, so that is an interpolation between the two lines on the extremes, right? And I guess with this parameter, we could do for bar. So let I equal 0, I, blah, blah, blah. So how many steps? Maybe let steps be, let's do 15 for now. Steps minus 1, and we'll do I plus plus. So in here, we're going to really quickly say that this is going to be I, and I is going to be steps divided I. So right. Okay, so we're interpolating, and now we could, we could put here more, and then we'll get further grid. And I guess, like, that's, maybe let's make this mouse X. All right. All right. So we got something. This is LERP, but this doesn't really solve what we wanted to render, which is this line, right? This requires a different set of math, which I don't know if I'm prepared to do right now. Okay, so we have this thing here, and we do. So let's go back to the page that we have before the Seekers page, and we'll try to find how to draw. Um, okay, marker. So we're trying to see how to calculate the each of the points on a Bézier, right? And this is new for me. I haven't done this with a function before, but I want to see graphically. Oh, okay, I understand now. So basically, you get the you have to go from this line in this direction and from this line in this direction doing the lerp, right? Where 0.25 is the parameter in this line, and also in this line. And the same thing happens here. So, okay, that seems doable now that we have this. So, so the lerp, we have the parameters there. And what we're gonna do is, so let's leave this for now to, let's comment this out. So let's leave this to 10 steps, right? And what we wanna do is get, I was gonna point with my finger, is get a, so if I leave this as it is at the beginning, right? Oh, not like that. Mm, okay, so, all right, so if you imagine the, how can I do this? Okay, so let's try this out. All right, so we've frozen this properly. Okay, so I do have this curve here, and what I'm trying to do, have this point, and this point, these three control points, but I have this curve and this curve, and we want to lerp, to interpolate from this one to this one, right? From this vector to this vector, this location, zip, going from here to here, zip, going from here to here, and then on the curve that joins wherever we're here in parameter t to wherever we're here, at parameter t also in that line, we'll get the points in this Bézier curve. And we're going to do that right now. So how do we get started? So we're going to go to our interpolation function here, and we have this, and these points. So we have the 3 points, and we're actually gonna name them, so A, B, and C, maybe. I don't know, like, so this is V1. It's a bit confusing, right? The nomenclature that I use, but let's say V3 create vector P3x, P3y, and then we'll do the same for P4. All right, so we're not going to do this right now. And what we want to get to is a, so we'll do, let's see how they refer to this, right? So this is the brown segments, the Castells algorithm of building the 3-point Bézier curve, right? Okay, so let's take a look at the Castells algorithm to build a 3-point Bézier curve, right? So if we have these lines, as you can see in here, okay, so let's actually make an intro in case I edit this. Hi everyone, it's Nono here, and this is a quick hands-on example on how we can use the Castells algorithm in order to draw a Bézier curve with 3-point roll coin. The Castells algorithm. Hi everyone, it's Nono here, and this is a quick hands-on coding tutorial on how we can use the Castells algorithm to draw a Bézier curve with 3 control points. If you see the brown lines that we have here, we can calculate just by joining the 3 control points of the Bézier curve, and we can survey a parameter from 0 to 1 in both the 2 brown lines, but also in the line that joins those 2 parameters that we calculated, always in the 3 lines with the same parameter t. 0.25 on the left and 0.05, so 0.5 on the right. And you can see that process dynamically being done in here, right? So let's see now that we have a P5JS. So now that we have a P5JS sketch, so, okay. So, okay, let's close things here. So we have this P5JS sketch that allows us to draw already this Bézier curve and the 2 control lines, right? Like this control point here. Now we're gonna add programmatically how to calculate each of the points, because right now the Bézier curve is being calculated automatically by this begin shape, vertex, Bézier vertex, and end shape functions that are native to P5JS. So we want to do that on our own. Let's see how we do. So I have here a loop. So I'm interpolating along the lines in a loop that basically is gonna iterate 10 times. So this is gonna be 10 parameters for t. And we'll say that t, actually t is gonna be e divided by the steps, right? And if we print t, you can see that that we're actually getting 10 parameters from 0 to 0.9. So we'll need one more, and that we're gonna do by removing this -1, right? So now we go from 0 to 1. We have 10 steps, but actually 11 points. All right, so the first thing, let's try to draw those points along these 2 purple lines that we have here. And I'm gonna create, we have these points here that I call P1, all right, so this point here is P1, the one that I'm moving is P3, and this one at the bottom is P4. So we're going to create a vector for each of those, and we can actually calculate the coordinates of, let's call it T1, right? A T2, and then Tx for the line that we're gonna do to join the 2 parameters. So first we said T1, which is gonna be, if we copy vector 1 and call the lerp function, we can lerp it, let's say, to v3x, v3y, and 0 in the parameter t. And we can do the same for t2, which is going to be in this other line. And this is from v3 to v4 in that direction. And now we're going to draw those points. So this is t1 and t0, and we're going to do draw those control points, or those I don't know how, those parameter points. Display parameter points, stroke, and this is going to be t1x, t1y, t2x, t2y. All right, so those are all the control points at every time step, and we probably want to make that radius a bit smaller in these points. Or even maybe make that they're black. All right, so we have those parameters, and I'm actually gonna use the same color that we're using to draw the other. So I want the stroke to be the purple color. Stroke, weight, stroke, feel. All right. All right, so we do have those. Maybe we can make it slightly darker. All right, so we have those parameters, and by changing the steps here to 5, for instance, we can see we have less, or now we have more of them, right? So we could either do this or animate that parameter to get the animation as we have it on the other video. So what we're gonna do now, let's leave it at maybe at 6 steps, and what we do now is to draw a line. So we're gonna draw a line between t1x and y and t2x and y. All right, and we get this kind of hyperparaboloid, or however you want to call it. And we're going to do this again with maybe the y of the mouse. Right, so when we do that, we're iterating, or like we're increasing the amount of points that we get there. Which is pretty cool. Okay, I see there's something happening here. That the Bézier curve is not exactly on the same position than the other one, right? You can see that it starts getting closer and closer the more subdivisions we put, but it doesn't really get to be the same, right? So let's try to make this 50, like a really high number. Yeah, so this doesn't match, so I'm not sure what's going on. Maybe I'm doing something wrong, and we need to figure that out. But that's interesting. So let's try to see this a bit better, right? The thing with these curves is that even if we have less of them, I think the points have to be on the same exact position than if we had more points. So the important points to construct our curve, if we were to do it by ourselves, would be that now that we have those those curves, right? We have like our vector, it's a line from here to here. So we'll say like the parameter or the vector in t1. So we want a vector. So these are vectors, right? So we could do here, we could say let t3 be p5 vector lerp. I think it's p5 vector, right? Between v t1 and t2, and we'll put it at t as well. And now we'll draw a circle at that point. Maybe, okay, t3. All right, you see those points there? Those are points. So those are points at the same parameter than, so we have, here we have 3 lines, right? The first line from the start point to the control point, the second line from the control point to the end control point, and then we have the third line, which is like 1 per parameter t. We can survey the lines at many parameters, and at the same parameter that curve is surveyed in the first and second line is being surveyed in the line that joins those 2 points, right? So I'm gonna make this, so let's say we have no fill here because it's the same color, and I'm gonna make here that the stroke color is gonna be something like this, so it's actually darker. Well, is it darker? So this is a stroke. I want the feel. Okay, let's do here no stroke. I think it's no stroke, what I'm looking for. Okay. Okay. Right, and we'll put this at 75 so you can see the points. Right, so those points are now bigger and they're now green. Okay, so the thing with this is let's maybe make the amount of subdivisions, these steps, a, so I think we can do math sin frame count. Okay. All right. Cool. All right. So maybe let's do something like this. We have some sort of animation, and we can make the animation greater, but the speed lower. All right. And we're drawing this afterwards. So let me calculate T3 here. So these are, this is the lines joining parameter points, convex whole lines, edges, and this is point at parameter t at edges so this is point in at parameter t in joining line. I don't know how to call that. All right. So we have this, and now we can choose when we want to draw each of them. And the last thing I want to draw, so I'm not sure why parameter points lines circle. Why are the points below? I don't understand that. Like, this is the line, right? All right, so what we can do, I'm not sure why this line is being drawn above the points. Maybe just like, well, let's make this bigger. Still there. All right, so there is something that I don't fully understand that is happening when we draw the curve ourselves compared to how the Bézier curve is being drawn, the Bézier vertex. Might be because we do have 4 points in that curve instead of 3. Not sure. All right. Anything that we get. So let's save this thing and I'll put the link on the chat. So this is P5JS sketch, the Castellanos algorithm. And yeah, I mean, how come is this working differently, right? Like how come, let's just put a ton of parameters here just to test this. Okay, it's doing stuff, right? But we get in red the line. Basically, it's like with many points it's drawn there, right? This starts to be heavy because we're drawing a ton of stuff every second. All right, so that works. I mean, this is just me playing. Um, but there is this offset between the line that P5 is drawing and the one that I'm drawing, and I'm not sure why that is. Specifies vertex coordinates for Bézier curves. Each call to Bézier vertex defines the position of two control points and one anchor point of a Bézier curve. Adding a new segment to a line or shape for WebGL mode Bézier vertex can be used in 2D as well as in 3D. Can we maybe not have the first vertex? All right. Well, that doesn't work, right? Vertex must be used once before calling Bezier vertex. Right, so that doesn't work. Okay, so this is let me comment this out. So this is our method to draw the curves, right? So let me stroke weight equals 2. Let's say 2. Right, so let's maybe do just 1.2. Okay, so this is our method. This is how we, or not our method, the Castells method. And this is to be working, right? So this seems to be doing the job properly. And, another thing that we could do to make a slightly different version of this sketch. So let this to redraw. So we're gonna duplicate. So we're gonna have this. All right, let's go to our sketches. We're going to rename this one to the Castellanos algorithm, and then this one, what we're trying to do, 03. What we're trying to do here is the Castellanos algorithm. Animation. One parameter. Animate parameter. Okay, so let's just do that, and I'll rename this to. I'll remove the quadratic. All right, cool. It's really hard to describe these things. All right. So now instead of looping all the time between that parameter, so we're gonna play here, right? So now I'm gonna leave the point as we said. We're just gonna leave this so it's not gonna respond to my mouse. And what we want now, so we're gonna first hide the Bezier curve that P5 is drawing for us. And now that we want to do is draw these blue lines, but just one at a time and see where that is going, right? The thing that we can do is, now that we have all this calculated, we could join those lines, right? Join those red points. And I guess we could do that with begin shape and end shape. And now that we have that, we can start adding vertices at those points that are these ones, right? Yeah, okay, so that is our Bezier curve, right? But if we don't want to draw so many lines, we'll add a vertex every time. What just happened? Okay. No fill. Okay, so we can, let's say we remove those points and also we remove those lines. No stroke, no fill. Fill, stroke, stroke, fill. Okay. Let's just do this. No stroke, fill. All right. And this is going to be full opacity. All right, so that's our curve, right? And depending on how many control points we have is going to be more or less detailed. So we can see that, right? Like it's going to be really detailed or less detailed. But we don't really care right now about this animation. We just want to have a set of like a set amount of parameters along the curve so its definition looks good. So we could say, that these steps actually are just going to be 50, right? We don't do this math calculation and that's it. And we could actually hide or put like a lower opacity in those red points. And now, now we could go actually back at letting our mouse move the curve. Right? So now this we're drawing, right? We're rendering ourselves this curve with stroke weight, and we're going to do 1.2. And actually, let's remove the points. Cool. So now we do have this line here. And what we want to draw are those parameter lines. And the first thing that we can do is, outside of this loop, we're going to say that our parameter t is going to be, and now this is going to go like, let's first start with 0.5. And we need to do this thing that is being done inside. So we're going to do the same thing. So this is to draw quadratic Bezier curve. Sample by sampling points. And this is display lines to sample. Display sampling lines. or animate sampling line, right? So we do want to have all these, but we're just gonna draw one line at a time. So we do have these things, and we have T1 and T2 and T3, right? So we do have T1, T2, and T3, and we can draw also that line, parameter line. It's here, right? So the parameter line is there. It's really faded, and we're gonna make it a bit more visible now. So we have this. The opacity can be now 255 again, right? And maybe we do get one of those red colors that we had here. Okay. All right. So the line is there, and now we want to make the opacity a bit higher, so we see the line, and now we want to animate it from 0 to 1. So how do we go and get this parameter from 0 to 1? We can simply say something like math scene. Let's make it slow, and we're going to put the frame count, and then we're going to multiply this by 1, actually by 0.5 and 0.5, because that's going to go to the negative and the positive. So this here is going to give us a number from 1 to -1. So we're going to get either 0.5 or minus 0.5, and that will make this go from 0.5 minus 0.5, which is 0, or 0.5 plus 0.5, which is 1. So you have that parameter t, and actually that was already working in here, right? And we can make this slightly, so if I stop and play, you can see that simply by changing this to like half of it, for example, we make that parameter interpolation slower, right? All right, so we got this, and now we want to see the point that we're getting at each moment in time, which is simply T3, right? So T3 we already have, so we're just gonna have to draw a circle that is T3 in here. So we just draw T3, and maybe let's make the radius something pretty big so you can see it, and the fill. Right, that's probably too big. And maybe we don't need that color. We need the blue color again, which we're using to draw this. All right, and voila. Okay, one, to be more subtle. Okay, we got it. So I guess we can conclude this experiment here. So this is now our quadratic curve being drawn. Let's see, we can make it. So this is how you draw a Bézier curve with 3 control points, right? So that point that is moving along the Bézier curve has been sampled by just joining those 3 points, and sampling the 3 lines that you can see in light blue here at the same parameter. First from the first point to the control point, second from the control point to the end point, and then from the control point, so from the parameter point sampled at the first line till the parameter at the same, so the point at the same parameter in the second line, and then sampling the point at the same parameter on that line that joins both parameter points. All right, and if we were to quickly fix the number, right? So we can quickly fix that number that we're using. So let me zoom in again. So I could, because we're animating, let's see what happens if I uncomment this. Up, everything breaks. All right, so if we actually get that parameter here, so the one that we're animating right now, so if we set t to 0.25, right? So this 0.25 is the same 0.25 that we're seeing in this diagram, and we can get it to the middle in 0.5. And we can do that by just setting this to 0.5, and that's the middle, right? So we're moving the parameter along, and I think this is understood a lot better when you draw it, right? When you draw the parameter. And actually, the last thing we could do that I think might be good, might be, I don't know, let's see. So I want to draw the line as the point moves, right? So, and then undraw it as the point moves back. So we have these fourth notebook, and the only thing we have to do, because this is, so we're only gonna add a vertex inside here. So if t, and there are 2 parameters t, right? So we probably have a problem here. T, 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 t. I'm not sure what the best name is. T sample. All right. If t is greater than or equal than t sample, we're gonna draw these things. Let's see if this works. All right. That works. And I actually wanted to make it so it's smaller. All right, so this is how you draw it, right? So you go and sample the parameters, and okay. Right, in this one, actually, this probably doesn't make a lot of sense. It just adds noise, right? And I would guess that if we add more points, this is smoother. All right, great. Just do 150, because that way you don't see where it's been drawn. Okay, so we do have this here, and I lastly marker export as GIF. All right, so now that we have this animation, I'm gonna see how to export it as a GIF, and I do think on nono.mas as draw, I do have an application that allows us to export as GIF. Maybe not this one. Oh, I think it's weekly. So you can actually open this in your browser. You have to reverse engineer the keystrokes required to get this to work, but I'm gonna get the code from here and duplicate this once more. exportable as GIF. All right, so what we want to do is take a look at the source code here and see where what this does to be able to be exported to GIF, and add that, there's a lot of stuff here. We need the GIF variable for sure. All right, so let GIF. We do need no render, no polyline, nope. Setup GIF. Let's see what that does. So setup GIF in here, and so let's take a look. Setup GIF. Where is this? All right, let's take a look. So setup GIF, counter hide. We actually don't. I'm not gonna put UI now, even though the other one has UI. Worker script, JavaScript, vendor GIF worker.js. That might be a problem. So let's take a look. P5.js export as GIF. Right, we've been going for 2 hours and 12 minutes now. Exporting canvas as GIF. Aha. All right, so this seems like a helper function that will do the job for us, so we don't have to set it up. But I wanted to control it a bit more. So let's see, play, create loop. Oh, okay, p5 create loop. I personally don't know if I want to use an external library for this, even though I wanted to use a web worker. Okay, so we are going back to the former plan. So okay, so let's put here Bézier, and that's it for now. Okay, create blog, URL create. Okay, yeah, maybe we do want that number. Okay, what else we have? So we got a remote. So here we create a GIF, right? So we create a GIF unfinished blob, and we got GIF render, right? So that's when it's finished. So we got this here, GIF render, if recorded frames plus 0, save. Okay, so we have this. We are going to say, because we're going to only save at the beginning. So what we're going to do is let is GIF exported, and we say false. And if it's not exported, we'll add frames and then export and set this to export it when it is exported, right? So we draw, and what we're gonna say here is if t sample is more or equal than 1, we'll say print export GIF, right? So we're not gonna do anything, but we want to know that will work. So GIF is not defined. How can we, all right, reference something else? And for that, okay, so we are saying there that the GIF class that we require worker script. GIF.worker.json. So this is none of the math JavaScript vendor GIF worker.js. Okay, so this class here, maybe we can even load it from there. So we'll say script source from here, and then script. GIF is not reference. And actually that, if we see the source of Soruse, we see the source of none of the massless weekly, we actually can probably see that the GIF class is loaded also here, not the GIF worker, but this GIF. And we'll do add that one, not the worker here. GIF is not defined. GIF is not defined, but it is here. All right, let's do one thing. Let's actually download these things or upload them here. So I do know that I do have these ones in my desktop. So GIF worker and GIF.js. Upload file. All right, so let's see if that works. So sketch.js and GIF.js. Oh, wow. Okay, so that works. So now we have that, and we supposedly we can export GIFs. We're probably missing something else, but all right. So let's see this sample. Let's see the values of this sample. It's almost there. It's almost at so maybe let's do it so it's 9999. Do we get to 999? Okay, so it would have exported the GIF, right? And maybe let's do it like this. All right, so export GIFs happens, and this way we can say that GIFs is exported, right? So GIF would be exported here. To do export GIF, and not is GIF exported. All right, so we export the GIF and we don't export it anymore, right? If that happens, that is, and I see that there's some people online. So if you want to say hello on the chat and tell us where you're connecting from, we're trying to save a GIF of this animation so we can share it on social media or, do whatever we want with it or put it on slides and presentations. Okay, so we have almost everything that we need, and now we just need to add frames. So git dot render add frame, CELT delay 30. I don't know what delay means. Copy true. All right, let's try to put this here. So git gif add frame. I don't know what CELT is. Let's see, create canvas. Okay, so the canvas, and we're gonna put it here. So let canvas, and we'll do here, when we set up, we'll say that canvas is this, and ELT. Right, so we have the ELT. Are we using the canvas anymore? Nope. So CELT. And now here we're calling it canvas. GIF render. Let's just try to see if we can export a GIF with one frame. All right, we get the GIF render, and we want to print here as well. So print finished. So let's do here get finished. Just to see if this method is actually being called at all. So setup GIF is being called, so the callback is being set. But this is not happening, right? Okay, so this GIF worker, this is wrong. Okay, awesome. It seems that you may have accidentally written save as instead of save. Save as. I don't think so, but where is this save as coming from, right? So that's what we need to figure out, because I do think this is coming from this file saver library, and we have that here, save as. Yes. Okay, so we have save as, and maybe we can simply save it as and add it here as well. So we'll add it as a file, saver min. So we'll simply do this. So we're gonna add one more of these lines here. So we're gonna add one here, but this one, oops. So this one actually just needs file saver. Okay, so let's save index, and okay, I see that a GIF has already been saved here. Let's see, let's see what this is. Woohoo! And if I open, all right, so we do have this image here. So this is our Bézier image and has been saved from the P5 sketch. And so if I open my downloads folder, that is here. So this is a GIF. So let's actually keep this open for a second below. And what you're gonna see now is that we just need to add more frames, right? So how do we do that? We'll just see what logic we follow. But as you can see, what happened is this is the latest frame where the curve is completely full. But actually, okay, let's actually see, because right now we're gonna get the curve filling, but not going backwards. All right. So let's close these things. Let's see our preview here again so we can see what we're doing. And I now have to only choose when we save. So add frames like this one, right? So, okay. So the delay is actually the time that we want the frame to be there. Okay, let's not auto refresh for now. All right, so we're talking about we're drawing and we want to add our frames always here. So render if finished. Okay, and here we'll say if GIF is not exported, right? Because if we export it means we've finished. We'll add a frame. Add frame. And this is probably going to be a lot of frames. So maybe we want to skip a few frames. And to do that, let's actually print, let's say, frame count every 5. So we can, let's try doing this. Okay, and we don't have frames, so it will fail. Okay, sketch. We go to sketch, and what we're gonna do, we're not gonna render anything, so this doesn't fail. Okay, so we see that we're getting these values from 0 to 4, and we're basically skipping 4 frames if we do this, right? If we say we're gonna save now this is thinking. All right, we cannot print something empty. Okay, so what we were doing here is if the GIF is not exported, but also frame count its model, so let's say we're going to skip every 9 frames or 10, equals 0. So we'll skip a bunch of frames and then we'll save. So for example, we can say here console log, and then we can say save frame and then frame count, right? And now if we play this, you see we save every 10 frames, which is great. Export GIF. And so here we're saving a few frames, not too many. Maybe we can save a few more, but for now we're just going to do this, right? So we're saving those frames, we're exporting, and we don't render because we don't have this set. So let's do once again. We save a few frames and then we're done. And now we get these frames saved. Okay, so let's see where we started. Okay, so we have this GIF, which is awesome. I mean, the fact that this worked is pretty amazing. But I see that the script starts earlier than this actually gets to save something, right? And I'm not sure why that is. So let's try just this really quickly. Or frame count equals 0. So we save the first frame. Okay, so let's do this. All right, so now we're saving every 10 frames, and let's allow this. Okay, so we're saving a ton of files here. All right, so let's simply, let's not auto refresh. All right, so let's stop this. Let's run it once. We add these frames. All right, and for some reason we are starting at 0.5, right? And that means that actually our script is starting at 0.5. So what we're gonna do is shift our frame count. So here we'll do plus, so plus 2 by pi and play. So let's see what t sample is at each of these frames. So let me see. Okay, so we're adding frames. So instead of say frame, let's say add frame, and we can say here the value of t sample. All right, as you can see, we start at 0.5 or more or less 0.5, frame 1, because we don't start at 0.1. So we actually, what we're gonna do is we're gonna do here frame count -1 and play. All right, so now we get 0.5. So this is cleaner. Math sin. Oh, we just need to. Okay, so let me. Actually, we could use pi, but let's just try to use cosine, and probably that solves our problems. Frame 1, 1. Sine minus pi. Okay, let's actually not export anything. Okay, now it starts there and it goes back. So we get from 0 to 1999 and 0, 1999, boom. All right, so what we could do, because this is actually going from 0 to 1991, we can say all right, so we'll make one that is so 12 5, right? 12 5. So this is half of the half of the speed of the other one. Let's see if that works. So we get this here. Play. So when the GIF is ported, here we're in half more or less. Okay, let's try this once more. Okay, so this gets at 0. This is half of the speed. So now we can actually let it render. Let's try that. Now the GIF is being created on the background and our GIF is here. All right, this is good. Great. Awesome. Now we just need to try to make it a bit slower with the delay, maybe half the time. All right, and we'll see it here. You see now it's a bit, I mean, I can see it that it's a bit jaggy, right? So it jumps a bit. So what we're gonna do, I'm gonna leave it at 30, but I'm gonna add here, I'm gonna make this 5. So probably we're gonna add double the frames. Yeah, so we're gonna add every 5 frames. And now we export. So this will have double the size, but be half the speed. So we'll have this here. Still smooth. All right. Awesome. All right. So now I'm just gonna make an outro. Great. Okay, so we save. This doesn't need to save, and we go to Twitter where we're gonna save our GIFs, and I'm gonna go to Live 64, and we got our Bézier curves. Fast. No, so this is slow. Wait, what did I see here? All right. Hey, it's okay, Sajeh. Nice to see you around. Like I'm glad that you could make it at least. I'm sharing on Twitter the outcome of what some of the things that we did today, and I'll just point people to um, basically let's see. So I can open here the edit URL of this live stream, and this is a how to draw Bezier curves, and this is actually what it is, right? How to draw Bezier curves. All right. So how to draw Bezier curves. And yeah, let's just share this here. Hey, okay, so I see, let me distract myself a bit from this, right? So I can see people connecting online. And okay, so just to show off a bit, so this is what we got to today. So we drew programmatically a quadratic Bezier curve in P5, and we animated it, and we exported it as a GIF. And this is something that I wanted to learn because the virtual sketching paper actually outputs quadratic Bezier curve, and we need to know what they are and how they affect the results on the paper. Uh, so Sajed says, and I'm gonna move to the right. Sajed says, so this week I was conducting a workshop on creative AI processes for a bunch of undergrad architecture students in a college in Mumbai. It was mostly no code or very little code. I would love to learn more about this. I would love to learn what you taught. If there is material that we can take a look, maybe a GitHub repo, some PDFs, some documents, I would love to see it. Even if you send it just to me, if you cannot share with everyone or something, I would love to learn more. It sounds awesome. Creative AI processes. That's amazing. Rob says that he's checking in briefly from vacation, In is this the it's not gonna it's not gonna tell me. And then Sajay Kumarji again says, but I introduced them to Runway ML, Low AI, teachable machine that you had shown on your stream a while ago. Awesome, that's awesome. I would love to also see the results of your students. I would love to hear your thoughts on what is the best way to introduce the subject to new enthusiasts without getting too technical. Yes, I'm actually also looking to develop things for that, Sajeb, because it's a fairly complicated or complex topic, and we I actually I did this. I feel ashamed that I had to Google it because I wasn't sure if it was Puerto Rico or not. But thanks for the clarification. And Suggest says that he's gonna share the things that he did on the Discord. So if you're watching this later and you don't have, Rob, just for you because you're there all the time, we went through a recap of these things, right? Like what we've done, and we actually I started this new section on Bézier curves today to understand them, explain a bit the theory behind them or the math. This is an exercise we actually did. I borrowed this from another website, cited here, but cited in the other corner, right? And yeah, and we actually saw the parameters, and yeah, so this is basically what we did today. And there is some activity here. So somebody joined, Sorab Matre and Gulsum, and probably we need to put here the live 65 and okay. Yeah, and probably we can just copy the links from here. I'm putting them on the chat for now. I hope to find somebody to help me organize them and maybe put these links on GitHub instead of having them just on the chat or on Discord, so people can follow through the uh, through the GitHub repo. I would like to work with you on creating materials for the program if you'd like. So yeah, that would be awesome. So we have I actually I'm bringing in also Juanda, so Juanda Cabrera Cobo. So he's also gonna be helping, so we can maybe create some sort of workforce, so we can join forces and we can prepare the outline together. We'll do it live. We might do it on meetings on Zoom or something, and yeah, but any help is more than welcome. I'm trying to look for an image. So luckily for me and for Juanda, so if I can open this, cannot open here. I need to open this on Dropbox. So I'm just gonna show Juanda the other day shared a story on his Instagram account. He actually happens to work really close by, so he found the live stream, and he actually happens to work close by where I record. So the other day we were able to meet in person. We've met in person a few times, and he is gonna be probably helping us also um, organize the course material. So we're all trying to learn, and I'm happy to hear that Sajed you um, that you want to help. And Rob is saying that he's loving the narrative recaps of live sessions on Nonodogma. So that is for those of you who don't know what those are. If you look for live in the blog, you can see blog posts that you can also get if you follow on Twitter. Nonoma says that's a retweet of the blog because I don't share everything on my personal account. You can share this account, and all of those posts are going to be automatically shared by Zapier. So they all end up being shared here, and you can see here, for instance, right? So with that, I tried to make a recap of what we do on the live stream, and I think I do have one prepared for today, and there is also a blog post for tomorrow that talks a bit about what I learned um, to prepare this live stream, right? So this is, for me, this is great because I produce more content for the blog and I clarify the things that I write. So now maybe I can replace this video with my GIF, and yeah. So thank you guys. I mean, you make the project a bit more real, and I would say we need to, yeah. It's the community meeting is long overdue. I can't I can say sorry. I mean, I know we just need to do it whenever, and that needs to happen soon. So we have to schedule that. All right. So I was doing this. So here a tweet for the live stream, and we'll put here AI sketching. We'll put here artist. All right. So let's do this AI sketching. P5GS. Quadratic Bézier curves and where to find them. All right. Okay. Bye, Rob. See you. Enjoy your vacation in Puerto Rico. All right. So let's. All right. Let's tweet this. Boom. And we are done. Okay. I think we can. All right. So this is the tweet, and it would be great if you like it, if you retweet it, if you share it, so that people know that we're doing this on the live stream. And I think that's it. I think maybe I just need to share this last sketch. Latest P5 sketch to export to animate, export as a GIF. Okay, done. And just for you, I'm gonna share that we have a new cover on the channel. So I might update the image, but this is starting to look like this. Live streams on Thursday, machine intelligence for designers, and there's more stuff. There's the Getting Simple podcast, and there's um, geometry and other things. But for now, I'm just gonna get that going there. Okay, and I guess we could export this as a video as a last thing. If we do that today, let me quickly share the tweet. So Twitter, no, ESP, and I can get this here, and we'll share this. Okay, actually, let me finalize the post that I was gonna do for today. I finalize it now, so everything is done. Right, in today's live stream, we continue learning about how to vectorize sketches with machine learning. Today's focus was quadratic Bézier curves, 3-point Bézier curves. As I said last week, it's more productive for me to study some of these topics offline and share my findings live. Tomorrow, I'll share a write-up summarizing what I've learned about this type of curve. We're a step closer to understanding the virtual sketching's code and model architecture. We um, we not only saw we covered theoretical we we saw an overview on Bézier curves and implemented a few different implemented them with native p5.js functions. So p5.js functions with the what is it, Bézier vertex, Bézier vertex native p5.js function, as well as and programmatically by hand. We also animated, we managed to draw auxiliary lines to make the creation of Bézier curves easier to understand, animated it to see how to sample points, and exported the resulting animation as GIF, which are convenient, which are a convenient way to share them on social media and messaging platforms. All right, and here we're gonna put an image, quadratic Bézier curve point sampling, and we're gonna put here the image when we upload it. For my CMS, I can simply go to the folder. I can choose the slow one. Has a lot of margin. Not gonna edit right now. And we're gonna drop here. We're gonna say, so let's see, post live 65 Bézier curve animated. So we click here and we simply put this here, mark down, and we take a look at the post, and that's here. As I said, a lot of margin, which I don't love, and I guess I'm really annoying. Like I said I was gonna leave, but I need to do things right. So we probably want to duplicate this and just call it tight, remove copy. All right, so this is I think 05, unless we've done 204s. Yeah, we did 204s. So this is 05 and this is 06. 06. All right, so now we can go to 06 and I am going to play this. Oh, don't play because I let's not render. Make GIF equal false. All right, so we'll go to my sketches. All right, so we'll open this. We'll do this make GIF false. Yeah, I don't know what's happened. All right, so let's go again to my sketches. Let's duplicate it. And I can save, right? All right, so what we're gonna do, we're gonna delete the other one. So this is V2, so I'm gonna delete this one, delete. Okay, so we have this and I'm gonna make here, make GIF false. All right, so if make GIF is false, make GIF and make GIF. All right, if make GIF is false, no GIF is made. So this is our script, and what we need to do now is that we're going to make the canvas maybe 250 by 250. The drawing is now a lot smaller, but what we're gonna do is that we're gonna set the points to be tighter. So this is gonna be 95 and 05. 05, 95, 95, 05. All right, and now that's a tight GIF, and we could actually make it a bit tighter. So, um, mm, 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 mm. All right, so if we do this, that is even tighter. Awesome. And actually, So this is like this. We could actually now do something like this. That's pretty cool. All right, and make give true. All right, so now we see below here, GIF is exporting, exported, and we can also see it in here. So on purpose, I removed all the padding so we can share it online without borders and no padding. So this is slow, no padding. And this is the one that I want to show on the website, right? So not the other one that has a lot of padding. I want to be able to control how this shows on my own. And I mean, both options are good. So let's actually get the name from here. We're going to drag and drop this, put the actual name, replace. Image has been replaced. And now this probably won't show because the base image is okay. We almost confused it. All right, so I need to purge the cache, and we'll add the limit class here. All right, so we get our so this is the image, but I'm gonna purge it. So this is the cached image, and in a bit this should, this should update and we should get the new image. All right, so now it's good. There you go. All right, so I think this is pretty good. Yeah, I don't know if people will understand, but yeah, this is good enough. All right, so maybe the last thing we can do is a link to these things. So this is the one that saves the other one, right? All right. Here's the Right, let's see this one. All right. So let's see how this looks. Here are the P5 sketches. Okay, maybe we can simply list this. Right. All right. So okay, so this is gonna go out soon. So we have this. Right. I think this makes it. So we got the post. Let's see if all the links work properly. So we got 1, 2, 3. Wait 1 second. All right. So first we got the Bézier curve, Bézier vertex, which works. Second, we have this one, and then this one. This is number 5. All right, so I guess in here we're gonna revert back to maybe 300, 315. All right, we'll leave it like this. I guess we can go back here. We can say, oh, this is number 5, so the link is wrong actually. So this is the good one. Okay, so we get here. We test the last link. And then we say play. So this works. And then we say here true. and that saves it in here. All right, note that we haven't done it, but you could stop this and you could do something crazy like this, and that would be how your GIF is saved. So that's the craziness. Okay, and that's it. Save. And this goes out right now. So we'll go here, debug time. What time is it on my website? And we publish like this. You see, it says it will go live in 2 minutes on the blog. Right, and we'll put it here. Okay, that's it. Good to go. This is going to be published in a minute. And is tomorrow's one. Okay, so this is literally right. So you can see here the time on the website is 49:59, and the post doesn't show yet, and 54, 55, 53, 56, 59, and boom, and now boop, the post is there and we can see it. All right, so we're gonna link from it from the other one, and tomorrow we'll mention this so people can go to today's post. But maybe we don't want to open a new tab, so we'll preview and do this. Okay, we've covered everything here. So the outro hasn't really been an outro. We've been doing a bunch of other stuff. I've had fun, so I'm gonna try to do more live streams like this one. I hope you enjoyed it and you got a lot out of it. And I will, in case somebody's there, I know that maybe Sajja is here. Um, Please, if you're watching this, like the video if you haven't so yet, to support the work that I'm doing here with the channel, with the videos, with the tutorials, and subscribe if you want to get notified when I go live next or when I upload new videos. It's my pleasure, and you can join us on the Discord community. There are links all around this page. And yeah, thanks a lot for watching, and I'll see you next time. It makes me really happy to see that you connect online. So if you can put the notifications on so you know on your phone when I'm live, and maybe on the first 5 minutes you just join and say hello, say where you're connecting from, or what you want to learn, or anything, or maybe share what you're working on and we can talk about it on the live stream. So yeah, without further ado, I'm gonna close the stream. Thanks a lot. This was a 3 hour and a half stream, and it passed like it was no time. So thanks a lot. Bye.